Okay, today we're going to look at section 3.1, quadratic functions and their applications. So let's start off with a function defined by f of x equals ax squared plus bx plus c, where a does not equal 0, is called a quadratic function. By completing the square, f of x can be expressed in vertex form as f of x equals a times x minus h squared plus k. So first thing, the graph of f is a parabola. With vertex hk. So this is one of the helpful hints of that completing the square that we learned. Next up, if a is greater than 0, the parabola opens up or upward, and the vertex is the minimum point. In other words, the minimum value of f is k. If a is less than 0, the parabola opens downward with vertex hk oops, scratch that, and the vertex is a maximum point. So the maximum value of f is k here. We also have an axis of symmetry. Which is x equals h. This is the vertical line that passes through the vertex. So let's look at this. Here we have a parabola. Okay, f of x. We have a vertex here, which in this case is a minimum. And our vertex is HK. Then I have a line of symmetry here, x equals h. In this case, a was greater than 0. Looking here, again, here I have a vertex, HK, max equals K. I have my line of symmetry here, x equals h. And here a is less than 0. So let's look at an actual function. See what we got going on here. So I have g of x equals x plus 1, or x plus 2 squared minus 1. So first off, open up or down. Well, a here is positive 1, so opens up. Second thing to look at, what's the vertex? If we go back up here, it's x minus h. So I have x plus 2. So my vertex is negative 2, and it's plus k, so negative 2, negative 1. Okay. What else can we find out of this? Well, we could find intercepts. We'll find the x-intercepts by setting y equals 0. So when is g of x equal to 0? X plus 2 squared minus 1. Add 1 to both sides. Take the square root. Plus or minus 1 equals x plus 2. Subtract 2 from both sides, and I get 2, or negative 2, plus or minus 1 equals x. Negative 2 plus 1, x equals negative 1, or x equals negative 2 minus 1, negative 3. So that makes my x-intercepts negative 1, 0, negative 3, 0. Okay, next let's look at y-intercepts. For y-intercepts, we set x equal to 0. So I got g of 0 is equal to 0 plus 2 squared minus 1 is equal to 2 squared is 4 minus 1 equal to 3. So in this case, we have 0, 3 for the y-intercept. We can sketch this. What do I know? I know 1. I got these 2 points here. 0, 3. Got a point up here. Got a vertex at negative 2, negative 1. And I know it opens up, which goes with my points here. Determine the axis of symmetry. Well, remember the axis of symmetry is just x equals h. X equals negative 2 right here. Okay. Do we have a maximum or a minimum, and what is it? Yep, this is E. This is F. G, we have a minimum, and it is the point -2, -1. And lastly, the domain and range. Well, what values of x will work? Well, this goes on and on forever, and so does this. So the domain is -infinity to infinity. The range, well, my low point here, my minimum is -1, and it is included. And then it goes all the way up to infinity. And there we go. And all this we can pretty much tell just from the equation when it's in this form. So how can we write this in quadratic or in vertex form? So we'll start with f of x equals 3x squared plus 12x plus 5. What we want to do is write the equation in ax minus h squared plus k. I want f of x equals a times x minus h squared plus k. So I can do this. 3 times x squared plus 4x plus 5, right? Not quite what I'm looking for, but it's closer. So if you remember when completing the square, we had to have a 1 in front of the squared number. So let's keep that 3 out here. Now I have x squared plus 4x. So b is equal to 4. 1/2 b is equal to 2, and 1/2 b squared is equal to 4. So we're putting 4 in here. Now, what exactly have I added? It's 4, but it's also times 3. So I've actually added 12. So I need to subtract 12. Okay, and then we know that this is simply x plus 1/2 b squared, and then this is minus 7. So now I have it in the right form. So now let's see. Identify the vertex. So the vertex is, again, I have plus 2, so that's -2, -7. That's my vertex. Okay, next thing we're going to look at is x-intercepts. So to find our x-intercepts, I'm going to set this whole thing equal to 0. 3 times x plus 2 squared minus 7 equals 0. So 3 times x plus 2 squared equals 7. Yep, that's not how we looked at it. They use the original equation. That'll work. Let's go back to that. So if I need 0 to equal 3x squared plus 12x plus 5. So now I can use my quadratic formula. X equals -b, which is 12, plus or minus square root of 12 squared, which is 144, minus 4 times a, so that's 12, times 5, which is 60, all over 2 times a So I get negative 12 plus or minus square root 84 over 6. And at this point, we can just leave it like that. So I'm looking at 12 plus or minus square root of 84 over 6 and 0. Next up, we're looking at D, and we want to find the y-intercept. So F0 equals 3 times 0 squared plus 12 times 0 plus 5, which is simply 5. And I have 0, 5 for the y-intercept. We're not going to sketch this. I don't see any point in it. I guess we could. What do we got? Well, it gets messy because we didn't calculate the square root, so let's not bother with that. F axis of symmetry. What? X equals negative 2, right? G. Okay. Where are we at? Where are we at? There we are. A is positive, opens up. So we have a minimum at negative 2, negative 7. And H, our domain is negative infinity to infinity. And our range is, again, our minimum value, negative 7, is included all the way up to infinity. Okay, so that's pretty long drawn out method is here to find a vertex. So needless to say, we came up with a different way to do this. So for f of x equals ax squared plus bx plus c, where a does not equal 0, the vertex is given by negative b over 2a comma f of negative b over 2a. So let's look at f of x equals, let's go back up here. Let's go to this one. 3x squared plus 12x plus 5. 3x squared plus 12x plus 5. So let's look at this. Negative b is 12. 2 times a, which is 3, comma, over f of whatever that is. Well, let's do this separately. Instead of doing that, let's do this. So we have negative b, negative 12 over 2 times a is 3, negative 12 over 6, negative 2. So I now know my x is negative 2. Then to find my y, I simply plug in negative 2 in here. I find f of negative 2, which is 3 times negative 2 squared plus 12 times negative 2 plus 5. So here I have 3, negative 2 squared is 4. Here I have minus 24. Here I have plus 5. This is 12 minus 24 plus 5. Negative 12 plus 5, which is negative 7. Negative 7, which is the same thing we got here. So now let's look at some applications of this. quarterback throws a football with an initial velocity 72 feet per second at an angle of 25 degrees. Now, this is not trig, so we won't need to know how to do this. It's given to us. The height of the ball can be modeled by h of t equals negative 16 t squared plus 30.4 t plus 5, where h sub t is the height in feet and t is the time in seconds after release. So what I'm looking at is my quarterback standing here, and he shoots this ball like that. Determine the time at which the ball will be at its maximum height. Well, it will be at its maximum height at the vertex, right? Since we have opening down. To find the vertex, I simply take negative b over 2a and f of negative b over 2a, or in this case, h. So negative b over 2a, well, negative b is negative 30.4 over 2 times negative 16. Negative 30.4 over negative 32. And get my calculator. $30.4 divided by 32. And I get 0.95. Now I need to find f of, or h of that. So h of 0.95 equal to negative 16, 0.95 squared plus 30.4 times 0.95 plus 5. Now I will tell you, there will be a test question like this. And the two most common errors is not squaring this or forgetting to put that in there. Now let's look at this. Negative 16 times 0.95 squared. I get 0.9025 plus, and I have 30.4 times 0.95 gives me 28.88 plus 5. Now I take negative 16 times 0.9025, and I get negative 14.44 plus 28.88 plus 5. And this is 19.44. So my vertex is 0.95, 19.44. So the question is, determine the time at which the ball will be at its maximum height. 0.95 seconds. Second thing is, determine the maximum height of the ball. Well, we have that as well, 19.44 feet. And lastly, determine the amount of time required for the ball to reach the receiver's hand if the receiver catches the ball at a point 3 feet off the ground. So we're going to solve this where h of t, the height over ground, is 3. Now negative 16x, or t squared, plus 30.4 t plus 5. Okay. So we're going to subtract 2 from both sides to get this set up. 0 equals negative 16t squared plus 30.4t plus 2. Then we can use our quadratic formula. T equals negative b, negative 30.4 plus or minus the square root of 30.4 squared minus 4 times negative 16 times 5 over 2 times negative 16. Okay, so doing a little math here. Plus or minus the square root of 30.4 squared, which is 924.16. This becomes plus 4 times negative 16 times 5 plus 320 all over negative 32. So we have negative 30.4 plus or minus the square root 1244.16 all over negative 32. Okay, it's one of these rare instances where we can estimate this. Take the square root of 1244. So I get negative 30.4 plus or minus. And we'll go to, let's just go 1. 35.3 all over negative 32. So what happens here? If this is plus, this becomes 4.9 over negative 32. Okay, if this is minus, this becomes negative 65.7 over negative 32. This value here is going to be negative. We're talking time. Can't be negative. This value here is going to be positive, roughly 2 seconds. 5.7 divided by 32 is, and we'll round to 2.05 seconds. And going back to our drawing, remember, this started at 5 feet. So we go to 3 feet here after 2.5 seconds. The reason we have a negative number as a possible answer is that would be if it went backwards. But we don't go back in time, so at least not yet. If you know a way, please let me know. Okay, and then last thing on here, regression models. Now this is same process. Oh, wait, I've skipped one. Let's look at this one. Farmer has 200 feet of fencing and wants to build 3 adjacent rectangular corrals. Determine the dimensions that should be used to maximize the area and find the area of each individual corral. So I know my fencing. I have 2y plus 1, 2, 3, 4x. That's going to give me 200 feet of fencing. And really, I can make this easier on myself. Y plus 2x equals 100. That's one equation I have. Now, the entire area is xy equals whatever. I don't know. So what I can do is solve for y. And now I want to maximize the function x times 100 minus 2x, which is, we got f of x equals negative 2x squared plus 100x. Okay. So now I can solve for x. or I'm wanting to maximize this so I can find a parabola. Negative b over 2a equals negative 100 over negative 2, or 2 times negative 2, negative 100 over negative 4, which is 25. So if x is 25, y equals 100 minus 2 times 25, y equals 50. So now I know x is 25, y is 50. Now we want to know the area of each of these. I can do this two ways. I can just do x times y. 50 times 25, which is 1,250 square feet. And then I have 3 corrals, so each corral is 1,250 divided by 3 square feet. So now let's look at regression. Okay, this is done the same way in your calculator. So we'll have a t and we'll have an f of t. 0, 3.5, 3, 2.2, 6, 2.1, 9, 3, 12, 4.9, and 15.8. If we were to put these on here, actually, let's do this. You can see that these points are going to look something like this. So we see that they look like a parabola. And we want to find a quadratic function to model this data. So we follow the same process as we did with the linear. So we're going to hit stat, edit. If you got anything in there, delete it. Okay, make sure you have nothing in line 1, 2, 3, or any of the other lines. Or list, I should say. So here, this is list 1, list 2. So we have 0, enter, 3, enter, 6, enter, 9, enter, 12, enter, 15, enter. Then go to list 2, 3.5, 2.2, 2.1, 3, 4.9, 8. Make sure you have the same amount of data. Okay, so we list data, L1, L2. Now, we hit stat again. Then we want to calculate. And we want to calculate quad regression. On mine, it's number 5. Okay, and that's going to come up on the screen like before. Hit enter. And we should get, first we get the equation y equals ax squared plus bx plus c. Then I get a equals 0.0595, b equals negative 0.5929, and c equals 3.4857. So that means our equation is 0.0595 x squared plus, minus 0.5929x plus 3.4857. And we can do the same thing here. We can find the minimum, again, by finding the vertex. We can find the max, or we can find values for specific time frames and all that just like before. But this is where we're going to stop on this one. And I will see you next time.